Alright, so the story of question 8. Actually, there's not really a story, but maybe more general. So this is definitely one of the kind of questions that it gets harder with more like it doesn't necessarily get easier the more you know about maths. So there's like this optimal amount of ignorance to do question 8 and not worry too much. But obviously you don't want to like make yourself significantly dumber just to do one question in the Aimo. Okay. Um Alright, so lots of comments about question 8, but let's just start with what the question is. So it says you have 3 circles that are tangent to each other, all of diameter 1, yeah? So they're all the same size. Okay. And if you put a square such that 2 sides of the square are tangent to one of the circles, and that the overall square you make has minimum area, right? Or minimum side length, or it's as small as possible. So I guess I feel like the more you know about maths, the more sort of this issue about whether the square is actually minimum will bother you more and more, yeah? So I think you can definitely just be like, oh, right, so obviously the minimum is like this, touch 2 circles, and then do something like this, and then go on to pretty much get the wrong answer, I think. And so here's an example where like if you had no worries getting to the wrong answer like this, then I think that's a very big problem. Okay. The next maybe level is you might think, oh, actually there's another way I could try to get the square so that the area might be smaller. Okay. So maybe I can get it so it's like more in the middle instead of touching on the sides twice. It kind of more, so it's more like it's got a line of symmetry. Oops. Down the middle like this. And I think if you realize that was possible, I think you'd feel good enough about it to kind of go with it. And depending on where you are at your maths maturity, you might not worry about any other possibilities. Okay. Actually, in general, if you want to maximize something, um, the points which give you the maximum are usually either the extreme points, or the symmetric points. And so this would represent a symmetry down the diagonal, whereas the line that touches 2 circles maybe represent like one extreme, where sort of the 3 circles are like up against the top line as much as possible, or if it's like on the other extreme, they're like up along the sideline as much as possible. Yeah. Okay, so I guess depending on how much maths you do, the question of if the square is the smallest will be either on the back of your mind, at the front of your mind, or just not in your mind. Okay. So let's just see what happens if it's in the back of our minds. So we want to calculate. So let's assume that this is the smallest, okay? And maybe we'll try to prove it later. And even if it's not the smallest, you'll probably want to know what the size is for comparison later. So just assume it's the smallest and compute. But really you don't know if it's the smallest or not. Okay. Um. Okay, so we know the diameters are 1, right? So for example, we have this nice little square. So we know the tangent's always perpendicular to the radius, right? So I have a nice little square to match the square on the outside. Oh, can I get a bit of a microphone check just in case I've lost audio? Yeah.
Yep.
All right, sweet. So, um, okay, so there's some stuff happening here. There's 90 degrees. And then there's this nice thing that happens in the middle. So you probably know this, but if you join the centers of the circles, they actually go through where they touch where they touch, right? Because where they touch is like a tangent, and they're both perpendicular to the tangent, and so that's a straight line, right? Okay, let me just fudge this a little bit more. It looks like they're going through the same point here. And of course, it's an equilateral triangle, right? Because the sides are all the same length. Yeah, they're all equal to 1. So we have this whole thing is a 60-degree triangle. And now we record this axis of symmetry. Yeah, so actually when I did this question, I spent most of my time thinking about what the smallest square was. Actually, this part wasn't too bad, but you could actually like it depends on how you do it, I guess. It could get pretty bad. So for example, I think one nice thing you can observe, if you know this is 60 degrees, then this is 30 degrees, right? Because that's cutting it in half. And you know that this whole angle here, so let me put this in blue or yellow or something. This whole angle here, oh, that's too big. Only slightly though. So that whole angle there is like, oh, do you know what angle that is? You guys know what angle that is? Not quite 120, because remember, this is 45, right? Here. Yeah, exactly. So this is 135. So if that's 135, and this is like, let's just keep drawing then. This is 90 here, and that's 30 there. Then well, you got like 15 degrees left over, right? I'll draw that in some other color. Some emphatic black. Emphatic black. So actually, all we have to do is figure out this length. Okay. And then we know it's whatever that length is plus 1, right? Um, so, and we also know that this length here is 1, right? Because that's the radii of the circles connected. So you see that basically the length we're looking for up the top is cosine of 15 degrees. Yeah. So the actual length of the square is 1 plus cosine of 15 degrees. You see? So this is where you just get out your calculator, right? But you're asked to express your answer in terms of like a plus root b plus root c on 12 or something. It's still possible to do that in your calculator if you're kind of a little bit it's a little bit tricky, but it's not bad if you just need a square root, for example, because you could just square your answer. Yeah, oh wait, I don't have a calculator, which is good because it's probably better to do this without a calculator. So all you have to do is calculate cosine of 15, right? Cosine 15 square. So cosine of 15, do you remember, is equal to cosine of 60 minus 45. Which we know is cosine of 60 cosine of 45 plus sine of 60 sine of 45. And we know cosine of 60 because it's kind of easy to work out cosine of 60 because that's an equilateral triangle, right? 1, 1, 1. That's 60, 30, 60. That's a half. So cosine of 60 is just a half. It's also easy to work out cosine of 45 because if you have a isosceles right angle triangle, that's root 2, right? And so that's 45. So cosine of 45 is 1 on root 2, right? Similarly for sine, so this is root 3 on 2 as the height. So plus root 3 on 2 times 1 on root 2. Okay, so if you write that, it's equal to 1 plus root 3 on 2 root 2, right? Which is, if you times the bottom by root 2, you get root 2 plus root 6 on 4. And so for some reason, you would make it on 12. I don't know why. Yeah, was it on 12? I can't remember. But okay, so it's root, then you go times it by 9 plus root 54 on 12, right? So then when you add the 1, get 1 plus root 18 plus root 54 on 12. So your final answer, I guess, would be 73. Yeah, so it's kind of interesting. I think question 8 usually will be by far the hardest question, actually, mathematically, if it wasn't fake solvable. So here, this would be like sort of a fake solve because you had no idea, you have no idea why it's the smallest, but you have a good chance of getting the right answer. So you might check, for example, that the other alternative could not possibly give you the smallest with the two circles touching like that.
Oh yeah, isn't this the field of algebraic geometry or something like that? You just have these random tangencies and it just gets really strange.
uh
But in algebraic, there's really hardcore questions.
yeah, I guess the chord bash kind of stuff is very closely related to algebraic geometry.
Okay, I remember this extremely. I remember this random question. I remember it. It was how many conics are tangent to 6 given conics? And then the
Oh
answer
yeah,
was
so
quite
that's
massive. It was over 1,000 or something. And then I think someone
combinatorial projective geometry.
there was a lot of fake solves. But and then I think algebraic geometry talks about points in general position a lot. So there's no
Oh yeah,
degenerate cases.
indeed.
I think if I
Yeah,
look
so
up
we
list of mathematical errors or something in Wikipedia, and then lots of people, it shows lots of people stuffing up in algebraic geometry.
Oh yeah. It's funny, like so the book we were using for it was a Hartshorn. They had like unsolved problems in the exercises. It was quite interesting. Oh yeah, so quickly, just like the other case, obviously this is a longer square because this has a length 2, right? It has a length 2 and 1 plus like cosine is always less than 1, okay? If you remember, it was like the unit circle, so the x value is always less than 1. So 1 plus cosine 15 is always less than 2. It's definitely not equal to 2. Um, how could you eliminate the other possibilities? So for example, actually the way we solved it was just computing the length. So if we just kind of did that a bit more generically, I think we'd be able to get it. So for example, if we drew a square, so we know that, oh crap, I'm drawing it on like the zoom, sorry. So if we drew a square, actually I have no excuse for drawing a bad one here because I had like a ruler tools. Like the circle, the circle that the square is tangent to basically looks the same relative to that square no matter what, right? So it's just a matter of sort of where the others go. So um you could have it like sort of, so one of them's always going to be touching and the other one's it could maybe not touch, right? So it could be that um so obviously one of them's always touching because you wouldn't waste space for no reason. So you would touch it as much as possible, but you don't know if the other side is going to be um the same length, right? If you touch it. So you don't want a rectangle, so you got to keep it sort of the longer of the two lengths. So you should always have at least one touching. And the solution we had both touching, right? Okay, so what you could do, so you still get this equilateral triangle business, right? So what you could do is you could try to measure. So we had this angle before, right? It was 15 degrees. Um, see this angle here. Now we can I guess we can kind of just keep it as like a pronumeral. So if it was 0, it'd be like this degenerate case where it was both on the top, and we see that if it was 30, it'd end up as the sorry, if it was 15, it would end up as the other one, the symmetric case. And if it were, so we just got to be a bit careful. So when this angle becomes 0, is when it becomes sort of the degenerate case on the other side, like this. So when this angle, so see this angle here is 90 minus 60 minus, it's 30 minus theta, right? 30 minus theta, because that's 60. You know, you don't want 30 minus theta to die completely. So your theta is basically between 30 and 0, right? Okay. And so if this is 30 minus theta, then can you see that this length here is cos 30 minus theta? Okay, because this equilateral triangle's length all ones, yeah? And this right angle triangle, like we had before, was cos theta. Okay. So if you went down this vertical path, okay, you would get 1 plus cos 30 minus theta, right? And if you went across the horizontal path, I mean, that would be the answer if it was the bottom that was touching, right? But it could be the right side that's touching. I guess without loss of generality, it's that's touching. But it might be easier to consider, so the other way as well, it'd be 1 plus cos theta, right? And so the minimum length of the square would be the maximum of the two, right? So the minimum of the two wouldn't help. So you're looking for the maximum of cos theta versus cos 30 minus theta. Okay. And to make it as small as, and you want to make it as small as possible, right? So you want to take the minimum over all the thetas. Okay, and then, you know, conveniently, if theta equals 15, right, then you get cos 15 for both of them, so the maximum has to be cos 15. So cos 15 is what you get if theta equals 15. You know, if you want to kind of make more sense of this one step at a time, imagine if you put theta equals like 14, right? Then you get the maximum of cos 14 and cos 16, right? Okay, but we know that cos is decreasing, right? Like if you have a right angle triangle, it's like the opposite, it's the adjacent, let's say this, it's adjacent, so it's this length here, adjacent over the hypotenuse, right? So as the angle gets smaller, the adjacent side looks more and more like the hypotenuse, right? But as the angle gets bigger, so if it gets smaller, it looks like this maybe. The adjacent side gets big, right? If it gets bigger, the adjacent side gets kind of small, right? So in this case, this would be just cos 14. Okay, and cos 14 is bigger than cos 15, right? So if you took theta less than 15, you'd get some cos less than 15, and that'll be bigger than cos 15. So this actually shows, so what am I, so theta equals 13, you get cos 13, right? But the thing is, cos 13 is bigger than cos 15. So no, and if you pick theta to be bigger, like theta equals 16, you get cos 14 again, right? It's just symmetric. So it's actually quite easy to see that from this that this is the maximum or minimum. Okay. Yeah. So you might be thinking, what's the point of doing all that if you could just get away with it? Well, that's kind of like trying to rely on luck at the casino to make a living, right? Um, kind of like I'm just gonna buy lottery tickets to support myself because it's worked for some people. And also this kind of certainty, while it's not doesn't seem to be worth any marks in this question, is actually worth all of the marks in this more and more senior questions. Yeah. Okay. Any questions about that? Microphone check.
Hello.
Oh, good.
Okay, good. So let's look at some stats for that question. So you can see question 8 is essentially the prize cutoff for year 8s. So you have these um only 82 people out of 2,500 people got this question right. I think you get one question. You probably get one question for the diagram. Yeah, pretty sure. Ayush was saying that too. Get one question for the diagram. I'm pretty sure you get one question, one mark. Sorry, one mark for the diagram. One mark for writing. One mark for probably some process that um works out the answer. Okay, so something that does something with, and I think it has to be the right configuration. Okay, so maybe one mark. Oh, I should also mention in the answers there was a nice kind of reasoning for why 15 was the maximum. So another way to do this was, so basically you want to show that not just one side is touching, but you want to show both sides are touching, right? And so the reasoning is, if only one side was touching and there was some like space over here, you could rotate it about so about how the two circles are stuck onto the fixed circle, so that there's a gap on both of them. Okay, and so if there's a gap on both of them, it meant that one of them could have been squished further in to touch the circle, and so therefore they both had to be touching, and that's a really quick reasoning um to say that that's the right configuration. Actually, so to say it's the right configuration, that's worth one mark, I think. Yeah. So obviously the marking criteria is not this strict. I'm pretty sure. I don't know. Actually, Yasser is a marker for AIMO, so maybe he can tell you. I don't know. Did you do it last time? We had James Bang on last time. I don't know if you did it last time. Oh,
Marked AIMO, you said?
yeah, yeah.
Oh, no. Oh, no, I was still in school.
Yeah, of course. Of course you are. I keep forgetting you're only like 18. All right, so um yeah, so one mark, so the marking criteria I'm pretty sure is not that strict, but I don't know. You can ask Yasser later once he's done it how much they forced him to mark it a certain way. Um yeah, one mark for the diagram, one mark for like reasoning that it's the smallest square, one mark probably for any progress in calculating that, and obviously 4 marks for the answer. Yeah, so a lot of people fake solve question 8. So it's actually a fake solve when you can't actually justify it in any way, not even like implied by the question. But it's still like it can still get you the right answer. So it's kind of like a lucky fake solve. Yeah, so you can see only 82 people got it right, and 50 people got prizes. So this is definitely one of the questions.
I think there's also questions where it's too hard to rigorously prove, but it's just easy to assume something and get the
Yeah, yeah.
answer. Or
So
in,
that's
yeah.
that's the sort of the Achilles heel of question 8. So even like you know, like Jeff's perfect score in Aimo was definitely a fake solve, like a fake solve for question 8. So lots of people fake solve question 8. I remember Haibing had a good fake solve question 8. Yeah, anyway, so alright. Any questions about question 8? Alright, let's be transitioning.